Okay, so I'm going to record the momentum practice problems for you. And when we look at them, the very first one says that you have a baseball with a mass of 0.2 kilograms. Here we go, craziness. Let me get rid of that junk. So here's my mass. Now it's batted, or pitched, we should say, so that's the initial velocity. 30 meters per second. I'm going to make that be positive. And it comes back at you at negative 50 meters per second. And you're looking for the change in momentum for part A. So part A asks for delta P. So delta P is equal to m delta V. All right, so we're looking for the change in momentum. So the mass is 0.200 kilograms. Change velocity is final minus initial, so that's negative 50 minus 30. So delta P is 0.200 times a negative 80. And 0.2 times negative 80 is going to be delta P equals negative 16 kilogram meters per second. Now, your answer might have come out positive because you picked your direction opposite of mine. You are still just as correct as I am, so don't feel bad. It's okay. Now, part B tells you that the bat is in contact with the ball for 0.002 seconds, and it wants to know how much force was delivered. Well, we have F delta T equals M delta V. So F delta T is 0.002 seconds. M delta V was negative 16 kilogram meters per second. So the force is going to wind up being negative 16 divided by 2 times 10 to the minus third, which is a negative 8, times 10 to the third newtons. And that makes complete sense because if you're batting the ball, you're hitting the ball away from the batter, and away from the batter is a negative direction, so that makes complete sense. Okay, number 2, a lot of folks struggle with number 2, so let's talk about that one. You have a ball that has to hit the ground. It falls a height of 1.1 meters, and the mass of the ball was 0.420 kilograms. It hits the floor, and then it pops back up, but this time it only goes, so that's its initial height, it only goes a final height of 0.8 meters. Now the reason that happens is the floor absorbs some of the energy, so the speed that it hits the floor with is not equal to the speed it leaves the floor with. But I don't have either of those speeds, so I'm going to find them. So I'm going to say on the way down, KEI plus PEI equals KEF plus PEF. There is no KEI, starts from rest. There is no KEB. There is no PEF because it's on the ground. So I have MGHI equals 1/2 MVF squared. So gravity, 1.1 meters is equal to 1/2 VF squared. And when I did that, I got the speed that it hit the ground with to be 4.69 meters per second. Now I want it to pop back off the ground. So I'm going to say KEI plus PEI equals KEF plus PEF. Now when it gets to the highest point on the way back up, there's none of that left. And it had none of that to begin with. So I'm going to say 1/2 MVI squared is equal to MGH final. Math will cancel. I'm going to have 1/2 VI squared is equal to 9.8. times the final height of 0.8 meters. So it's going to leave the ground at 3.96. Now be careful because you've got them headed in opposite directions, obviously. So one of them needs to be positive, one of them needs to be negative. I'm going to make this one be positive, and this one be negative. So what I know now is that they want me to find the impulse delivered to the ball by the floor. Well, impulse is F delta T, and it's equal to M delta V. So even though I don't know F or T, I can still get impulse because I can do M delta V. So my mass was 0.42 kilograms. I'm going to say my final speed is the speed that it goes up with, which is negative 3.96 meters per second, minus my initial speed, which is a positive 4.69 meters per second. So this is going to be about 8.65 meters per second. It's negative, and I have 0.42 of that. So when I did that multiplication, I got F delta T to be a negative 3.63 kilogram meters per second. And it makes sense that it would be negative because the floor is pushing up, and if the floor is pushing up, that's in the negative direction.
Okay, where do you put the,
All right, so we're going to try number 3. Mr. Knowles is probably going to come in and make a lot of noise. If he does, just ignore him. I'll try to also. It says, what is the momentum of a 10,000 kilogram truck? So part A, 10,000 kilograms. And the velocity is 20 meters per second. And they want to know the momentum. So that's just mass times velocity. Very easy. So 10,000 kilograms times 20 meters per second is going to give me momentum of 200,000 kilogram meters per second. Now, part B says, and there's my answer, so I want to box it. Part B says, what velocity must a 5,000 kilogram truck have to keep that same momentum? So mass is 5,000 kilograms. Momentum is 200,000 kilogram meters per second, and so I'm going to say, well, P is equal to mv, so 200,000 kilogram meters per second is equal to 5,000 kilograms times V, and V is going to be 40 meters per second. And most of you did quite nicely with that one. And you didn't show me work, though, and that didn't make me very happy. Okay, number 4, we're going to skip. That's one with the angles in it, and I'm not going to get to that this year. Number 5 says 2 blocks of mass 300 grams, but I can't leave it in grams, so I'm going to make it 0.300 kilograms. And mass 2 is 0.200 kilograms. Now they're moving toward each other, so one must be positive and one must be negative. The heavier one is going to be mass 1, and it's going to be moving at 50 centimeters per second, or 0.50 meters per second. Velocity 2 is going to be the lighter one, and it's going to be moving at 100 centimeters per second, but I'm going to make that be a negative 1, because I'm going to say it's moving to the left. They're going to collide and stick together for part A. So I'm going to have M1 V1 plus M2 V2 equals M1 plus M2 times the common velocity V prime. So I have 0.300 kilograms at 0.5 meters per second plus 0.200 kilograms at negative 1 meter per second has to equal 0.300 added to 0.200 times V prime. So this gives me half of that is 0.150. This is a negative 0.2. I'm going to get negative 0.05 kilogram meters per second. I'm going to divide that by 0.5 kilograms. And when I did that, I got C to be equal to a negative 0.10 meters per second. So that was pretty painless, as long as I paid attention that they were moving in the opposite direction so that I had to make one positive and one negative. Okay, that's the new common velocity. And then B says, what was the kinetic energy of each block before and after? So I'm going to do mass 1. KE initial is 1/2 0.300 times 0.5. Don't forget to square that. So the initial KE there was 0.0375 joules. The final KE for that one was 1/2 0.300 kilograms, meaning at negative 0.10 meters per second. I'm going to square that, and when I do that correctly, I get 0.0015 joules. And then I need to do mass 2. KEI is 1/2 m 0.200 kilograms. B squared is negative 1.0 meters per second squared. That gave me the initial kinetic energy of 0.100 joules. And then KE final for mass 2 is 1/2 m 0.200 kilograms. Now we use negative 0.10 meters per second squared. And if I did that correctly, I got 0.001 joules. So that one wasn't bad. Just had to pay attention to the sign. Okay, number 6. Number 6 is your mass is 80 kilograms. And they want to know what would your speed need to be so that you would have the same momentum as a 1,600 kilogram car moving at 1.2 kilometers per hour. So I said, well, the momentum of the car is 1,600 kilograms. And I'm going to leave it as 1.2 kilometers per hour. Technically, you should probably put it in meters per second, but that's okay because everything's going to work out in the end. So when I did that, I got 1,920 kilogram meters per second. No, I'm sorry, kilograms, and then I had kilometers per hour. And so your momentum is going to become 1,920 kilometers per hour. And you're going to set that equal to 80 kilograms times your velocity. And your velocity, your speed, is going to have to be 24 kilometers an hour. And that makes sense because this is actually, 20 times more massive, so your speed needs to go up by a factor of 20. All right, I'm going to stop, and then I'll record 7 through 10, and we'll be done.